First of all, my name is Vaibhav Khatri. Yeah, and I am here to give a small presentation on a audible now. Yeah, so first of all, let's start with the introduction. My name is Vaibhav Khatri, and today I am here to give you a demonstration and present some material. Yeah, on mechanical keyboard design on Zephyr. Yeah, okay. So let's first see how a simple keyboard works. Yeah. So as many of you know, in keyboards we have close to like 100 or 110 keys. Yeah. So the trick to read all of the GPIOs here is to put them in a switch matrix. So what happens in a switch matrix is that if you see all the columns and rows, they are connected to a GPIO. So the polling happens here. So every time if you see one of the columns, it is pulled high, and the corresponding row columns, it is pulled low when you do a key switch. Yeah. So the column high, if you see, it keeps on changing all the columns and uh, doing the uh, putting the high signal on every GPIO. Yeah. And then when you do a key switch on any of the other corresponding rows, that key gets detected. Yeah. So it is not a big task. Even the simple or cheap microcontrollers can do that as well. Yeah. So this is the working of the keyboard. Yeah. Now our part on it. Yeah. So our keyboard design runs on the Zephyr mechanical key. Okay. Yeah. So our keyboard design runs on the Zephyr mechanical keyboard. Yeah, which is kind of like a framework, or you can say a simple build application that is available on Zephyr that you can use to build your own keyboard. Yeah. So next slides. Yeah. So the hardware that we designed for it, it is completely open source and fully available on our GitHub repository, hardware tinkerers. So the hardware files are available. The firmware files are also available. Firmware files on the keyboard code, as well as the bootloader and the custom key mapping that you can do. Yeah. So the process for using this thing is very simple. All you have to do is just fabricate the PCBs, yeah, if possible, yeah, and then use a any of the Nordic or Nordic DK boards, yeah, and use the SWD outputs on it to flash the bootloader on it first, yeah, and then once you are done with the bootloader, then you can use, or yeah, once you are done with the bootloader, then what you can do is on the keyboard itself you have a reset switch. Yeah, when you press the reset switch twice, it will show up as a external USB device, kind of like the same thing that you have on Raspberry Pi Pico, that is also using the same UF2 bootloader. Yeah. So when you do a double key switch on the reset switch, it will appear as an external device. Yeah. Yeah. Now in order to generate or build the code itself, you can clone the ZMK repo, yeah, and then follow the instructions given on it to generate your own UF2 image in order to flash it. Yeah, so right now I'll give you a demo as well. Yeah. So this is the reset switch on back of the board. If we press it twice, see, it has appeared here as an external media. So what we can do now is just generate the code and get the UF2 image and drag and drop to replace it. build command. Yeah. So the image itself has been built. Now let's go to the build directory. Yeah. The CMK folder, the build directory, then Zephyr. Then here, if you see, you have a generated UF2 image. So to flash it, all you have to do is just drag and upload it to the external device. Yeah. So now our keyboard has been programmed. Yeah. And let's do a demo test. Q, W detected, E key detected, R key detected, T, Y. So we can see our keyboard has been programmed. Yeah. So now the contributors for this thing. Yeah. So the ZMK itself is a framework created by Pete Johansson. Yeah. And the source code files for all the CAD and all the firmware, it is co-created by me and my friend Sristik Bhandarkar. Yeah. So one more thing about it is that all the files are open source. You can download the CAD files, you can download the firmware files, do the modification, and have the thing running on whatever key mapping you want. Yeah. So thanks. Hmm. 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 So that part of code, I think itself is handled by different routines. And that, yeah. So the thing is co-created. So I work mostly on the hardware side of the keyboard. Yeah. So my friend here today is not here to represent the thing. Hmm. So the switch matrix, yeah, that thing keeps on pulling and checking for any key press that is done there. If they are on different rows, yeah, they can be detected. Yeah. On same row, sometimes it is tricky to detect. Yes. So, yeah.
Can you shed some more light on how to create a different custom board? Because, for example, I'm using Vim editor, so I want to create my own custom board.
Hmm. So your own custom key bindings.
Yes.
Yeah. So for that we have the ZMK config. So what you can do here is that you can change the key mappings in your uh, tr60.keymap file. Yeah, and have the binding whatever you want. Yeah.
So the config file is based on some framework.
Yeah, the ZMK framework.
Okay.
Yes.
I'm not familiar with QMK, but in QMK you can add multiple layouts and like with the layouts and toggle between them. Is it possible?
Yeah, I think in ZMK same thing is possible as well. Yes. Yes, sir.
This project
Yeah, I think from the firmware side they have done course detection and all. Yes. Yeah, so for that we have a small PMIC on the board itself there that can take care of that. Yes, sir.
In the grid matrix, whenever it's pulled, right?
Hmm.
Are all the keys given same priority, or like are any of them given higher priority? Like usually on the
No, no, all of them are given same priority. Yeah, that depends on user. Like you can press any of the key. Yeah.
right. Do you have the latency number?
Latency numbers, no, that we don't have. If no more questions, then we can conclude. Okay. Thanks, people, for being here.